Hi everyone, welcome to another Common Lisp Study Group. I'm your host Ram Vedam with Atlanta Functional Programming. Today we're going to be continuing actually our discussion of the gtwiwtg library that we were looking at last week, which was a generator library that's available for Common Lisp, similar to Python generators that most of you may be familiar with, or if you've looked at generators of other languages, they're very similar. We actually looked at a very similar library in that of Series, although Series had its own kind of set data structure and underlying um, algorithms associated with that data structure. And a question that was interestingly brought up was, well, Series looks like it could do a lot of these operations, but a couple of them aren't standard. Standard in the sense that they're not part of Series because the terminology wasn't standardized until much later. If we went ahead and implemented something similar to that effect in Series, how would it compare to this generator library? Which was a very interesting question that I wasn't quite sure what the answer would be, but we tried a couple of things out, and I thought I'd present some findings today and maybe even have a live coding session where you could see some of the differences. So before we begin, I hope those of you who joined us on Wednesday for the High Talk enjoyed it. I do apologize, we had some technical difficulties during the recording of the High Talk, but those of you who missed it, who had trouble coming into the stream or saw a shoddy stream during the live stream, the actual current copy of the stream is available on YouTube, so you guys can take a look at that. And if you guys have questions, please post it in the YouTube comments, and we will do a follow-up video, probably answering those questions. Stay tuned to the meetup page, as well as the announcements going to be on the Tech 404 functional programming Slack channel, or even the Lisp channel on the functionalprogramming.slack server. So to get started, let me go ahead and create a project. And as I normally would, I'm going to go ahead and start up Sly, so I can use CL project to do this. Got to share your screen here. Oh, I thought I did that already. Okay, got it. All right. So let's go ahead and create a basic series VW comparison project. Oops, I have to actually go and first create that project. So let me first go and start creating. Let me first load CL project. And then go ahead and make that project. And let's depends on, and for my sake, I'll keep Alexandria, and we'll have a series and WTG. Now, those of you who are just joining us and didn't get a chance to see last week's stream, just a brief review of gtwiwtg. It is a generator library, but it is actually not available in QuickLisp. You have to go and clone it through the URL that should be posted in the YouTube description. And so once you clone it into your into your local projects directory, wherever, if you're using QuickLisp standard, usually it's $home/QuickLisp/local projects, or if you're using Roswell, like I am, it's .roswell/local projects to post local copies of all your Lisp projects. So that way it's available in the registry, and then you can go ahead and then do what I did, which is using CL project. You can add it as a dependency and it will go ahead and load it up correctly. So we can now load this guy. Series gtwiwtg comparison. Now, I know the project name is a little long. This isn't supposed to be a library, although depending upon how mature or how correct some of our stuff is, we can actually maybe make it into a library, some of these functions. So to get started, let me go ahead and load up. Let me just load up main.lisp, and then we can get going here. And to make ourselves a little bit more, at some point we may I may end up writing some tests for this and stick it into the test directory, and then when this is a little bit more mature, we can just go ahead and I'll check it in so that folks can have a reference to how to do some of these things. So last time when we talked about the generator library, there's a couple of things that I mentioned that were available in gtwiwtg that doesn't actually exist in, at least as far as I know, terminologically in the series library. One of them is, of course, the take command. Take, as many of you know, is pretty common with with languages like Haskell. It will grab an infinite series, and then it will go ahead and it will grab specific parts of the series. Now, if you're looking at, say, and I think it would be best to look at probably Haskell for this, but if you take Haskell, for example, and I'll just briefly write some basic things here. If you grab a list here and do an infinite sequence, you can actually grab a subset of that sequence by doing, sublist, let sublist equals take 10 from x's. And what this will do is it will go and grab from the beginning of the stream the first 10. gtwiwtg actually follows some similar semantics here in terms of this particular notation, in that if you grab, and we saw this before actually, if you try to grab and say, I think the best one to do this is to also show what we did last week. Give me a second here. If you recall from last week, if we ended up just using the same, the same generated twice, it'll end up giving you the same results. So if we take this generator that we created last week, actually I'll just go ahead and load it, and now we have it. If we go and grab the first 10 of this and print it out, you'll see that if we do it twice, we'll always get the same results. And the reason for that is and this is just again to refresh people's memories, the generator library, what it does is, although we created an infinite sequence, take being a consumer of that sequence, it actually stops generation after it hits the number of samples it's actually trying to take from that sequence. So once it hits 10 samples, it internally goes and tells the generator, okay, I'm done, stop generating. And if you try using the same generator twice, you'll end up getting the same error. Let's actually look at this just to really drive this home a little bit. So let's go ahead and say this is a copy of our generator, all evens, which we could do. And for folks who don't know this, this is just a thunked back generator that will only generate when we actually use a consumer on it. So if we go in and then go ahead and load 10 here, all evens, and oops, sorry. We do gen first. And then if we try to use this again, you're going to see an error that will pop up. And the reason it's for an error is because internally, if you recall, this dunked back generator data structure actually has a flag that will say stopped is true, meaning that it can no longer generate any additional things. In series, this makes, so let me just say what the limitations of this first, and then I'll talk about series. In this case, it limits the ability, like if you have a stream, say a network stream, a socket or some sort, or even a stream of sequences where you want to grab the middle, say not the first 10 elements, you want to skip the first 10 elements and then grab the next 10. In that case, then you would end up having to you won't necessarily be able to do that just as is using just normal take. Now, if I remember correctly, and this is one of the functions that we did not go and check out, but it is available, it looks like. There is a skip. So what we could do is if we go and regenerate this guy here, let's go ahead and regenerate it. Okay, so we now have our thunked back generator again. And instead of doing, let's say, this, we do this instead, which is we first skip and there's skip while too if you have a predicate that you want to also leverage. And then we skip the first 10 samples and grab the next. And again, this is just grabbing the next even numbers. This will go ahead and gtwiwtg skip is undefined. What? That doesn't look right. Uses a generator by skipping the first one. I messed that up. Let's make sure of something. Apropos. Actually, not apropos. I think I could just do this documentation. Skip. That's that it's there. So maybe I messed up the notation here. Okay. gtwiwtg skip, and then just do this first, and then I'll just grab that back. 10 storage. Let's see what happens here. Skip is undefined. That must mean that in this library it's not available, but it says that it's an exported function. So, says that it's in the library and I see it there, but let me see if I can use it in the project. yeah, it's not showing up at all. So this looks like this is a exported symbol that may not have been defined in the library. Let me just do one quick section here. Sorry for the small tangent, folks. Just give me just 1 second here. So it looks like he has an exported symbol, but in the library, but it doesn't look like the library actually has defined skip, which is interesting. I would have thought that exported symbols, I guess you could define exported symbols in your package, in your def package before, that's right, you can probably implement your exported symbols in your def package before you can actually define them. So, which brings me to an interesting point here. So this library is still fairly new. There's a couple of things in here that aren't complete, it looks like. Obviously, merge requests are welcome, pull requests are welcome. So I'm sure the author would enjoy seeing folks implement some of the API packages. But let's get back to what I was trying to point out. So although I couldn't show this to you, once implemented, you could have simply, if you just want if you wanted to skip the first 10 elements and grab the next 10, you could just use skip and then take. Now, in series, you don't necessarily have to do that. Now, if you recall, series actually is a data structure that hides behind its underlying implementation around this API to do lazy evaluation. What this buys you is the ability to do some pre-computation and then essentially replay different aspects that you may have generated before, or compute until you need to grab the sub-series, which is what they use as a terminology, because series is the top-level data structure of the actual series that you're grabbing. So let's take a look at an example of this, and this is kind of what I was trying to show. So essentially, this equivalent is going to be, if I remember correctly, my dot syntax. Let's do $skip 10 access. Yeah, this should work actually. Do that. This is roughly the equivalent of what we're trying to accomplish here. So what we're going to first do is we're going to first define a simple function here. The reason is that it'll be easier than that to me to run this in the REPL, and then you guys can actually take this as an example. Simple take, right? What this is going to do is essentially, this is assuming that you, if we're implementing this kind of functionality in series, is you are going to start always from the beginning and then grab the n elements. So Let's do that. That will be series, subseries, and then we're going to say series. So you're going to pass in a series to the subseries, to this function, and we'll grab this. Now, folks watching who's been through our series talks know that this may not actually work if you're going to be using the series approach to what's it? The series approach of creating what's called a not a scanner generator, a sink. So if you recall, let me just bring up this guy so folks can see this. This is called, oh right, not that one, test series. It is not called, it's a collector, sorry. I'm trying to make sure I give you guys the correct terminology here. So, series kind of expects all of their things to be registered as being optimizable series functions, as we reviewed. To make it so that it's at least consistent to some of the examples that we're going to be going through here, I'm just going to not do that right now. Eventually, when we refactor this later on, we'll try and make sure that it fits into the series pipeline, so that way everything kind of works. So in here, subseries takes in a series and takes in two offsets. So you specify essentially the series that you want to provide, the start index, and then the end index. And then this will go ahead and grab a series of elements for you. So one thing that we could do to show this is we can go ahead and do example take. Let's say we do 10 from series.scan range from 0 and you can see here what we did is we grabbed the first 10 elements of the series. Now, the nice thing about this is let's say that we go ahead and rip this guy out and put it into a let. Oops, sorry, a let form or series. Let's call it series, and we do that. All right. So if we call this guy twice, let's say we do this twice, and we return it, you'll get the same results. This is different than what you saw earlier with the gtwiwtg library. The generator library, once you stop generating, it just doesn't, it throws away this stuff. This data structure is a persistent data structure, the series data structure, which is one slight difference between the two libraries. And I think it's a very useful thing because you've cached your results that you might need later on. And so if you end up creating series data structures for custom scanners and custom transducers, you could almost be certain if you follow the same rules that we talked about in series, you'll end up essentially creating a persistent data structure that pre-caches anything that's been computed already. And you'll be able to retrieve those cached events whenever you can go and retrieve them. I mean, you need them. This is one slight difference that I think is a very important thing to be aware of, because that would obviously hit performance, but there's other ones that I'm going to also show you. One is, like I said, related to skip, although we just saw that skip doesn't actually seem to exist in the gtwiwtg library. And that is, if we wanted to grab what I was saying before, we wanted to do essentially the skip and move around, but yeah, you would have to essentially keep generating stuff using the skip take pattern to actually go and grab what you want, which might be a little bit. It might make the API a little bit cumbersome. So, but what you'd ultimately want to be able to do, if you're treating it as a stream, especially, is to say, you know what, I want you to grab, say, 10 elements starting with offset, 15 or something like that, from an infinite range, or a stream that you're getting from. So it waits until it actually either gets 15 samples, and what series does is, and this is somewhat of a hit on the series library, but certainly makes sense given its design primitives. It will pre-compute, it will compute everything until it gets to the first element of the offset that you want. So to show you this is, I'm going to create a different function called, let's say, take offset. And what I'm going to do is I'm going to go ahead and delete this guy, make this proper take. So this guy here. Okay. So this is now our thing. Let's make sure all that's good. Go ahead and clear the REPL. And let's go take let's see what we should do. I'm going to call this take n. Okay. So what I'll do is grab, it will be the same two arguments as before, except we're going to provide a key argument offset 0. Okay, that's defaulted to 0 for right now. When we do that, and let me just make sure that I'm doing. Okay. So when we do that, we're going to end up doing essentially the same thing that we did there earlier in line 9. But what we're going to do is I'm going to actually change line 9 to use this function in the just in case. So what we'll do is we'll do series, subseries, a series, and then let's do offset, and then offset plus 9. Oh, sorry. That's right. Okay. So now what this is doing is it's going to start from the offset and then go to the next n values to grab the next thing. So of course, since this is defaulting to 0, you will see the difference, and when I refactor it, that it's going to give you the same results. But first, let's actually go and look at what happens if we do take 10, and let's say offset. Actually, this is not has Lispy. Let's make this keyword argument from, just so that we're more consistent with how a lot of our keyword arguments are currently already in the standard library, and it'll be more consistent to everything else. So take n as from the series from, say, 11. Okay, and then now this from actually is the index again. Remember, it's the index of the inclusion element that we're trying to grab from. So if we run this, you'll see. Oops, that's right. I forgot that I changed this and forgot to recompile. Now, you can see here that we started from. Oh, that's right. I just realized something. I made this inclusive. To make this proper, we need to actually go n minus 1. So it's upper bound minus lower bound minus 1. So that's the upper bound is not included in the thing. So what I have to do is I have to actually decrement this guy. So let me go ahead and do that. And oh, sorry. Let's use 1 minus. All right. Okay. So now we're consistent. So as you can see here, take n actually just takes in from an offset, and it grabs the next 10 elements. But the more important thing to notice is that the series data structure is not closed, right? It's not closed at all, which means that you have the ability to keep this guy around and let it generate stuff for you. Now, obviously, if you're not using parts of the generated and cached results, that might be taking space. So you might want to be careful about how big your scanners should be in terms of what they're computing. But if you're leveraging, say, again, data structures or even resources where you don't necessarily know when you're going to particularly use a particular aspect of the stream, having this kind of flexibility to move around the stream is very, very useful. Now, you can see that since we provided this default for the keyword argument, this means that we can actually refactor this guy and just say take n 10, a series, and this should work. Oops, sorry. And there we go. Let's move this out here so that everything's more consistent. And you'll see that it's going to be the same results. Are there questions about this particular thing? And you'll notice that this is going to be pretty fast. That once you've pre-computed and once you've, once you computed it once, calling take every time is going to be pretty fast. So let's do a quick timing of this. We'll do, we'll grab 100 here, and then we'll grab another 100, starting with 101. And let's go ahead and just time these two. Oops, sorry. Oh, no, that's what I wanted to do. So if we do that, you can see, let me just pull this up a little bit, that it's negligible. And it generated these really, really fast, and be able to and you will versus let's just take, for example, what we were doing before. And what I'll do is I'll make a new generator here. Actually, I won't use the generator. Create a new generator. I'll just go ahead and do indexed. I think indexed would work. No. What was it? Let's see. I think I can just do gtwiwtg range. That should be good enough. Yeah. Time. WTG. Take 100. You can see that although it's also fairly negligible compared to what we saw earlier, series is still somewhat faster than gtwiwtg's generator library. Now, this is mainly because to get some of the flexibility that and the protocols that for the various generators to work, the author of gtwiwtg basically went and created a more of a pure class-based library for generator functions. whereas series isn't as far as I know, it doesn't have any class extensions, so you don't get any access to, say, writing a protocol for your various variations of series, and then be able to hook them into things. And so there's some flexibility there for different types of generators that you may want to write. And you saw that we had several types already available to you: sequence generators, thunk-back generators, as we saw earlier, range-based generators, as we see now. But the cost of that flexibility might be some slowdown. But it's, again, negligible, as you can see here. It's nothing. It's a 0.00063 versus, I think it was, 0.00004 for the difference. But it could add up over time. So do profile your applications when you're running through some of these examples here. Another example is, let's say if I wanted to actually implement skip. Let me see if skip is actually available in series. I didn't think there was. Yeah, skip is not. So skip is nothing more than we can actually now, given what we did now with take n, skip we could define as literally has a subseries, but I don't think we'd want to make it a subseries. Subseries is a collector. Let's see. Let's see here. Series.
Back to series, huh?
Oh, hey, hey, Michael. Welcome back. No, I'm doing a comparison between series and the generator library that we went through last week. So it's
very nice.
It's interesting. The generator library last week, some of the exported API that's available doesn't look like they've implemented it, but the symbols are there. So, so I was like, okay, I guess you defined your API. That's fine, but I didn't realize that some of them were there. So skip isn't there. Skip while doesn't look like it's there. There's a couple of other ones that didn't look like that they were implemented just yet. So I'm trying to essentially implement some of their API just in straight series to see if what the differences is.
I see. Cool. Hey, sorry to interrupt. I just joined, but how did the screamer stream go? I missed that one. Did it go pretty good, or?
Oh, it went pretty good. If you want, take a look at. I think it's recorded. It's already available on YouTube. We didn't go and dig into the compiler as deep as I'd like to, but I will say this: there is, if you go and look into that Screamer discussion there, it turned out that it was just like a nested level implementation of a macro expansion. I mean, we could touch base off of this if you'd like.
I'll watch the video and see how it went. It's just I've been very limited on free time lately.
No, I understand. That's fine. So let's see here. This guy is going to be a skip. So a skip is essentially going to be a series, but it needs to be this. It's a scanner where the offset is going to be changed. So what we would have to do is we'd have to create essentially a transducer in this case that would transform a series to another series. Let's pull up.
I keep hearing the term transducer in regards to series. Can that be assumed to mean the same thing as in the closure world, or no?
So I'll tell you what series, the definition for series transducers are. I don't know too much about closure transducers, and I wish somebody who knows a lot of closure to come and at least tell me how closure transducers work a little bit more in detail. But when I looked into it, closure transducers are more of a fold. let's see.
Oh, well, if you don't know it,
Yeah, it's like a reducer. So
I can go look it up.
I just gotta pull it up just to make sure I just say the right thing. So yeah, Clojure's transducer revolves around reduction and passing something into reduce, whereas series transducers are literally a transformation. So it could reduce to another series of a smaller size or a different type, but it literally means transform one series to another series. That's all what a transducer is in the series sense. All right.
Okay.
So think of it like a map function is what I think of it as.
Right.
Versus
I'll just
instead
call
of
it
reduction.
a transformer from now on.
Yeah, that's
so
fine.
I don't confuse myself.
whatever works for you, man. You could call it whatever you want. I just don't think Clojure revolves around reduce versus the series revolves more around map is what I kind of concluded based on reading the different sources. But folks who are on the stream and folks watching out there in YouTube land, if you know the difference, post it and I will let other folks know. Because I would love to know myself if I'm on the money on that or not. Rich Hickey, if you watch this, I doubt you will, but if you do, I would love to know the differences between series transducers and Clojure transducers, just so that we can get the terminological difference out of the way. So yeah, this is going to be a transducer. So this is, remember correctly to build a transducer. I just don't remember. Predefined collectors. That's fine. Generating some test data. Did we not write intermediate? I thought we wrote a couple of them before. Oh, I wrote it in the other one. Main. Let's see. No, not that one. Okay. This one. This is. Yeah, so I'm going to have to create series optimizable series function so that it's registered, which means this needs to be series defun. Now what I could do is I could skip. Let's do this. Is it a gathering? Maybe. Let's see what def gathering does. No, not a gathering. It has to be. Not choose, not mask. I think it could be either rescan or not a catnate. It would be. You know, sometimes it's very useful to keep the series manual as I go through some of this. I should. Let's see here. Where are the documents? this is the one. All right, so look at what until does. There we go. Previous, that's like an electronic circuit element. Collecting values. No. Choose if. Oh, yeah, I could use it. Okay, so I could use this skip. So let's say subseries. This would then
What are you
be
trying to do?
Oh, so I was basically trying to essentially create a transducer that would skip elements, which means I could literally just pass in a series. If I just made this into a series.
There's a function in series to skip elements. Let me see what it's called.
I don't think there was. There was subseries that you could do.
Every nth.
Every nth?
Yeah.
Okay.
Returns a series of every nth element of items after skipping m elements.
Every doesn't seem to be showing up here.
Oh, really?
It's one of those functions. The colon where they so skip. So you said every nth does what now? Let me go and look at this. Every nth. Doesn't look like I see this in the.
It might not be what you want, though. I'm not sure.
Yeah, no. So I basically
returns every nth element of items after skipping m elements.
Yeah, no, that's not what I want. Basically, I wanted what I did before, which is so you see this. I created take nth, okay, take n, which is essentially skipping elements by using this offset. So if you specify the right offset here, it will go ahead and it'll just move the pointer and give you a series. And we can see that here. If I just simply do this.
Yeah, so that'll return 101 through 200.
Yeah. So you can see that. And they're both series. I forgot those are series data structures. The hash z means it's still a series data structure. So that means that all I have to do is make this into a series optimizable series function. And this is now a transducer. So take n. Essentially is going to now you just pass in a series. No. The difference is we don't know how many elements. Yeah, subseries. So we do series, subseries. Do I need to specify optional below? Okay, so I don't need to specify anything other than the a series and from, which is going to be essentially 1 plus n. Yeah, because we don't want to include. No, it will be just n. That's it. This is now our series function. What? Oh, that's right. What do you mean? Optimizable. it doesn't take anything, does it? No, I didn't think it did. So why is it saying undefined function? Weird.
It might be because that's only valid. Like series defund might expand into that already. Like I think we ran into this the last stream I was on.
Yeah.
Where that would only work with an actual CL defund.
Defund, that's right. You told me that. Series defund probably
sure
already does that.
The logic is behind all that.
Doesn't look like it, but we'll see. Skip. Let's see here. Oh, right. I'm in the wrong package. What was it to switch packages again?
RS.
Thank you. I have to get used to this at some point. Let's see. Let's do this. And let's do series scan range from 0 below. Let's say 20. Skip 10. Just to make things easier for us. And it looks like it works. Although some folks might be thinking that this is going to probably skip the 10th element, but we're including that because that's the lower bound. We're skipping the first 10 elements that we provided. So this is obviously going to give you a proper.
It's a half open range.
Yeah, it's a half open range exactly. So, but folks who are looking at this are like, well, this looks pretty neat. This is you can actually go and implement a lot of the standard Haskell style, I guess, terms or functions that you're used to. Take, skip while. There's also take while. There's so many other ones that are available in Haskell. Some of which are redundant, in my opinion.
What about the drop ones?
I think
that's like the opposite of take. I think Closure has them too. I'm not sure.
Yeah, drop I think you could do as well, similar to what we're doing here, because it's another a drop is literally, I mean, this essentially, a skip looks like a drop right now, as it looks like it right, because we dropped the first 10 elements. But I have to go and look at how drop is slightly different than skip in terms of Haskell to really know the difference. Right now, I think that this is drop Haskell. Let me see. Let's see, skip. What did it say about skip? Building list, infinite list, index and search list. Maybe this. Builder, nope. Building list. Nope, those are scanners. What's interesting is I think a lot of the listless transformer stuff that Wadler wrote for some Lisp that he wrote that series was inspired of ended up going into the Haskell list library. So some of these names look familiar to me. Not everything. Dang it, why can't I find... Here we go. Deletes the first n element of the list, which is related to tail.
Oh, I see how to do it now.
Okay. Well, are you talking about for drop?
Yeah. There's actually a library that uses series to implement all those functional methods. Function. Here, I'll paste the link in the chat, I guess.
Go ahead.
This library looks rather interesting. You might be able to use this for future streams and whatnot.
Let's see this. Redirect. That's what I thought it would be. So his implementation or drop is essentially my implementation.
It can't be much simpler than that.
I figured. I was like, it has to be essentially the same thing that with subseries.
And drop while is right under that.
Yeah.
Which looks kind of complicated.
So a lot of these are just applications of subseries, which is kind of nice. At least, and that's what I thought it would be, just because subseries is very powerful. If you actually look at what the function signature provides and how you can actually pass stuff into it, and it also moves essentially the pointer around, so it's pretty neat. But I don't see. Yeah. So skip actually is drop. It's the same thing. So we just basically implemented drop here. Same as skip in gtwiwtg, but using Haskell for consistency. All right. Let's see.
Another really useful thing that comes up a lot, especially in Clojure, is the partition function.
Yeah, the partition function. That is.
Which looks incredibly simple in series as well. That's on line 210 of that link I sent.
So what is? Let's first talk about what is partitioning doing. So partitioning is basically creating two sequences from a series. One of which will be, well, two series from a series.
Yeah, like if you took the numbers like from 0 to 10 and you
split them between odds
it by being even, then everything in the first return value would be even and everything in the second would be odd.
Yeah. So if we do my partition, let's call this my partition. Then we just do pred, and then our series. Although I noticed that he uses series quite a bit here. I'll do foundation. I'll do a series because that's from the small talk notation. Okay, so this is just doing nothing more than it's just going to create two subsequences of this. So this is split if a series pred. That's it. So let's try this out.
Pretty easy.
Yep. My partition. Let's see this. My partition. And we're going to say even scan range from 0 below 10. And you get two series back. Multi-values. Pretty simple. Pretty straightforward. It's pretty nice. But for folks who are used to that, seeing the other like more declarative function things, it'll be cool.
I don't see an example in this link I sent on how to do the other really common thing that I've always seen done a lot in the Clojure world, especially, and that is I think it's called group by, or it's basically like if you wanted, like, say you had the numbers from 0 to 10. And you wanted to group it by 2, then it would create a list of lists with 0 and 1 in a list, 2 and 3 in a list, etc. Because you're grouping by every 2 elements.
Right. How would you do that in series? That would be interesting. Because you're basically, that's a transformer to create from one series essentially another series of pairs, right? So that's interesting.
Yeah, maybe it's called like pairs or something. I'm looking for the wrong thing. I know in Serapium it's called batches. I think it's called
batches.
But I think it's grouped by enclosure if I'm not mistaken. Comes up a lot though. It's one of those things that are like in every code base pretty much.
Group by. Let's see, what does it say here. Group by given a function and a collection. Returns a map of elements of collection keyed by the result of f on each element. Okay.
Maybe that's not what I'm thinking of. Let me see really quick.
This looks pretty interesting. I think this can also be done in a series by you have to first split it to map the predicate, and then you'd have to create you would have to create the map, but I don't think you can just simply create the map, because
yeah, so it's batches in Serapium, which it doesn't really tell what it's from. I forgot. I don't know, but it's called batches in Serapium. If you try that in your REPL, just batches, then some list, then a number, however many you want to group it by.
Oh, I've been following your kind of like suggestion and not load Serapium just because of how many libraries it pulls in.
It just pulls in way too many dependencies.
Yeah, but just gonna load it up. Serapium batches. Okay.
That'd be pretty interesting to figure out how to do in a series.
Yeah, would.
Just give it like 0 to 10 as a list, and then as the second argument, give it some integer, like 2 or 3 or something.
Okay, loop from 0. Oops. Just so that I don't have to go and start typing in so many things here. 2.
Yeah.
Nice.
But it's pretty useful to have.
That one might be a little difficult. Maybe.
Yeah, especially the edge case at the end.
Yeah. The edge case is going to probably really be a little interesting. That's inclusive too. So let's see here. So I'm going to call it batches as well, just because this way it's a little bit more consistent. And what it did is it took the series and then the element that you want to batch at. And what you have to do is you have to iterate through the series each time, and every time you get 3 n elements, it needs to stop and then construct the new data structure that's going to add to the result. So how would you do that? That's a particularly interesting.
Whatever you do, don't jump to definition for Serapium batches. It's like a bunch of code.
Yeah, it's kind of what I figured.
That ain't too bad,
but it's going to be
more complicated than it needs to be.
Yeah, I don't think it would work anyway, just because Serapium is probably using more of an imperative style to implement it.
Yeah.
So, let's see. Iterate is the same as mapping, except nil is always returned. Is there any way to collect in pairs? I'm looking at the series documentation just to see if there's something already predefined that I can actually leverage that will just dump things. Because as you can see here, and as I noticed the other day as well, quite a bit can be done with what's already available in the core API. this is just so that folks who aren't familiar with some of the terms can actually not go back and learn all of them. This will just be straight up useful. Let's see here. Series, hash z, don't care about that. Scan multiple. Ooh, wait, scan multiple. Oh, no, that's just creating multiple instances.
No idea. You'd need to have some accumulator to keep track of the temporary list, I think. I'm not sure how to do
I think I figured out part of it at least. No, scan sublists would have made it so much easier, but I don't think that that's what we should be doing. Okay, it's creating two p lists there. Scan lists of lists. No.
Might be able to do it with a transducer.
Yeah, that's what I'm thinking too. But I'm wondering what exactly.
Maybe you can implement it with subseries in terms of your take function.
Or you can also probably
take two all the way down until the end. Yeah. It's probably difficult to write in series without understanding it good enough.
Yeah,
probably a bad example to do on stream here.
Yeah, well, it's one of the things that that we'll be discussing. Even if it's something that I can't get to, well, I'll work on it and kind of report it. This is kind of how our stream works here, folks watching. Yeah, we figure things out, and if we can't figure them out, we'll go back to the drawing board, figure it out, come back and say, hey, I figured it out. It's going to have to be a transducer, and it's going to have to use a mapping function of some sort, because it's going to what we want to do is we want to collect until we get to a certain number of items, and then we want to push it down the pipe, and that's where the problem is, because you can't just simply doesn't look like you can simply just wait.
Yeah, and it's different than other I mean, if you're not mapping over elements, you're mapping over some arbitrary number of elements.
Right. So. It's basically a pseudo reduction, right? You're reducing this guy to a set of a different data type. So I have to think about this just to see how the mapping function would work in order for me to actually go and implement this. But this is that you gave me a challenge. I'm going to write this down.
Good luck.
Because if I can write this in a clean way, I think it would be cleaner in series than in Serapium. Implement batches in series. I have to obsess over it in order to get an epiphany. All right, let's move on. So there's a couple of things that I wanted to kind of really do this comparison for, and it's one of the reasons why I wanted to compare it. One is, as you can clearly see, although series itself was implemented, again, I mentioned this multiple times in our past series, talks about series, a very long time ago, almost 35 years now. Its core data structures and core APIs can implement a lot of the API functions that we're all familiar with today in a very, very straightforward manner with no loss in performance, from what I can tell, at least, from the basic examples that I've also demonstrated to you. And a lot of these libraries that are using that are doing more of an object-oriented approach using def generics and generic functions, and then creating sort of a type hierarchy for different types of generation functions, like we saw with gtwiwtg. I think there's another library that does something.
Fast.
It's really hard for. All right, so I said it enough times that I've gotten used to it. So,
I gotta actually leave for now. I got a party going on here, so
okay.
Sorry.
I know.
Thanks for the chat.
See ya. But the one thing that I wanted to bring up is the fact that the two libraries that we saw, both series and gtwiwtg, take two very different design approaches to implement their core APIs. That said, performance-wise, although it is true from the numbers that we saw with SBCL, your mileage may vary with other library. Lisps, whether it be CCL, Clojure, or Allegro, or some of the commercial Lisps. But based on at least my numbers with SBCL, it does seem that series itself is slightly faster. It is significantly faster. We're looking at probably, but the level at which, the comparison at which of their performance, in the large scheme of things, is very negligible. Okay, so that that in and of itself is something that I think is underutilized, and it shows that you can write stuff in an object-oriented fashion. And although it is slightly slower, at least with SBCL, it's fast enough to get some really big wins. So you'll get some flexibility with that design, and you'll be able to actually implement some standard generators that can be used across many different forms, and you'll get a standard API for free. But it doesn't give you the ability to do certain optimizations that Series has, and Series' approach and its design to actually create this kind of meta compiler over defining functions and defining pipeline functions is something that most people, I think, coming into Lisp may not think about as being kind of an approach to implement their system is. But I can tell you right now, at least from looking at Series and looking at even Screamer, if you looked at what we were talking about last week, that compiler-oriented approach to defining your API has a lot of wins in the Lisp space, and has a lot of wins in making code look very declarative and giving you the same performance guarantees that you would otherwise have to wait until a compiler writer comes in and implements it in your language of choice. So I'm going to end it at that, just because really the batches one is going to take me a little bit of while. I will certainly work on it and give you guys maybe a secondary stream just to my findings on it. But I have to really think about how the mapping function kind of works for it. So until next week, I appreciate you guys joining. I appreciate those of you who are on the live stream. Stay tuned for upcoming announcements on the AFP page, and I'll see you guys later. Thanks.